Hey folks, Jason Duke's Dirt Race Life. In this episode on our crate racing street stock builds, we're going to be installing the front shocks. We're going to work out the mounts for the lowers, we're going to build the towers for the uppers, and most importantly, we're going to show the technical details of how to build a right front bump stop system that works and will hold up. Stick around. We're going to focus our time here during this episode on doing the right front. So we're going to get in the details deep on this side, not so much on the left side, but it is simpler because there's not a bump on the left side either. Now the first thing I wanted to show y'all was, now that we've gotten everything done, I had to go back and start looking at how this shock was going to mount through here, and I was too tight on my space. And I had some people call me out in the comments on this, and I was worried about it. I knew I was really pushing my limits, and I had this out. I had to move my mount back a ½ inch in. When I was putting this in here and I was looking at how much room I had from the ball joint here versus where that spring was going to be in my bind. And the problem is even if I have just a little bit of clearance here, create a little bit of clearance, I'm going to make myself really tight over here, and then as I articulate up and down, get into a problem with the spring shifting around on the cup and getting into the side of the shock. It was too close, too marginal, and so for that reason I cut it back and I did move it. It does work, had a spring in it, everything's fine, but it's not perfectly at zero. And that's the reason I had not welded, and I waited. If you'll go back, if you're watching these videos through on series, you'll recall I left all of this open for quite a time, and I didn't know if I was going to cut in and block this in. The reason that this bar is across here is because that's helping to keep this from over time working its way up. You know, in other words, as the spring is working and beating on it, you know, slowly peeling it back. That support, and I hadn't put that in yet, but I did have some question of, in my final design, will it work out for me to be that far out? And it didn't. Now, on the left side, of course, I'm running, you know, this big, it's either 9.5 or 10 inch upper arm here. Plenty of room, not worried about the location. It's perfect to it. So on this right front, the shock that you're going to see us using to mount all this up, this is a 19 series Avco twin tube oil shock, all steel, non-adjustable. It's a 1973-8. So that makes it's an 8 on the rebound, it's a 3 on the compression. It is definitely a tie down shock. I'm probably going to go to a completely different set of matching shocks before it's over for this car. This is a setup that I ran on my Camaro in Crate Racing USA. I'm probably going to start out and try this starting out, but I may, you know, see what's going on and go to a completely different set of shocks. Just follow us through as we change. We'll be very transparent about that. It's a good place to start though. We're going to mount this shock with body up so that it is it's sprung weight and very little unsprung weight right here. And let's see, on the bottom, we're going to use a narrow mount because we're going to sit down in the control arm, and I'll show how that's going to work. We're going to use a narrow mount there. And then on the top, so this is a bump stop setup, and yes, I build these myself. I'm not sure, you probably can buy something similar, but I'm just not willing to spend the money. And I want what I want, not necessarily what somebody, you know, builds up there. All right, so that's a wide mount. The reason I did a wide mount is because I drilled a hole in the middle of it and I wanted room to weld it up. So this is a salvage jack bolt. I got a set of nuts on it. One of the nuts is just a lockdown. I'll probably take that off while we're doing it. The other nut, we're going to turn around and we're going to make ears and tie this onto a tower so this adjusts. This is key for building a bump stop system. And the reason it's key is because that the curve on your spring, what you're doing, if you just run a front spring, that spring is going to be linear. That rate stays the same as it compresses. It's a straight line up a chart. If you run a bump, what you're doing is you're creating the same effect as a progressive spring. Well, not only is it a progressive spring, but it's a progressive spring where you can have some control over how that rate increases. And so the bump itself, what it does is you're on your regular spring, and that's a straight line coming up the board, and then once you get into your bump, that line takes an arc upward very quickly, because the bump is going to have a much stronger rate as far as over inch per inch. It's going to make the spring rate spike, and you want to control where that spike happens so that you get your action, and then as you start getting into where you want the car to be and stay while it's tied down, you want to be able to adjust that bump to get that spot where you want it. And it is a art to it. I'm not gonna lie, we'll have to do completely separate videos on this, like at the track on test and tune day. Don't know exactly how we'll work it out, but we're gonna make it happen some kind of way. These are just, this mount is just an Allstar product. All right, when we mount this in here on the lower, I'm going to sit right down in this valley. I want to show y'all something that might seem just a little bit counterintuitive about how we're going to mount this, but trust me on this one right here. The closer I can get to the lower ball joint, the closer I can get, that gives this shock more control over the movement in this assembly. All right, so basically it's like a rate deal. So as I move back with the spring, what I'm doing is I am increasing the multiplication rate as far as how strong this shock has to be in order to control movement. That's one of the reasons that outboard shock is so much more effective than a stock location shock, is because you can get into tuning and really controlling the fine movement in your front end. And I am going to mount this up against this spindle. And of course you say, well, that spindle is turning and moving and that's rubbing. Well, we're going to weld it in, we're going to spot it and weld it in, and then this spindle is going to get cut, and I'm going to take and I will trim this back. I don't need all this. I'm going to take weight off this spindle, and every spindle I run, I always take and I will just trim clearance in, because I can take a 1/4 inch of that casting right there off and have plenty of room. Now, as far as the angle for the shock, this shock will not be in line like straight with this upper control arm. That's not how it will be mounted. I am going to put this shock where that the angle of the shock front to back is in line with the lower control arm mounts. So as this lower control arm moves up and down, it moves in an arc that goes rearward. I want this lower mount, as it compresses into this shock, to move straight up into this shock. I don't want one of these deals where that as it compresses, this shock twists and leans over and leans back, because that movement is taking away from my shock rate during that travel. It's creating this digressive situation that is unpredictable and not accounted for. If we run a digressive shock, we want that to be intentionally in the control of the shock, not because of the geometry of how we mounted it in the car. All right, so we're going to mount this with the rear. It's going to be facing rearward, and it's, that's difficult to measure, but basically I'm just going to go across and get it in line and come up with that good spot. It doesn't have to be perfect. The other point is the lower mount. We're not going to mount that lower mount straight up with the heim joint, always at an angle. We'll take and turn this lower mount as well to match it, so that we get our best strength and control on this lower mount with the least amount of wear. So we'll turn it as well. We'll spot the bottom, we'll spot the lower mount first, and then we'll take the shock off and weld the lower up completely. We can go ahead and do that, and that gives us our starting point. Important note right here, when you're welding with this shock in place, make sure you are grounded in a way that the voltage is not traveling through the shock, because you're going to wreck your shocks if you do that, and then they're going to be blowed out. You're not going to understand what's going on. You take them back to your shock guy, and he takes them apart, and he's like, yeah, you've got burns all inside here, or something to that effect. So be aware. Make sure anytime you're welding, same thing goes when you're welding on your engine or something, like unplug your MSD box, pull your distributor, whatever you need to do, but you want to make sure you don't pass voltage through these critical points that it could damage something. All right, so let's get that welded, spotted, and welded up first. I put a wood block in and I aligned it to my shaft down below here. So I've got my angle here set by this wood block so I can use it as a guide. And then all I did is I put the shock and I was looking for that 90 degrees. Okay, so you see how we did that? So we aligned our shock by creating, see that square corner right there? That's all we was doing. We're just using eyesight, that's fine. All right, so then once I had that figured out, now I could take and I could set this so that it's in alignment. My mount is in alignment with that angle. And I've got it up against my spindle. Again, we'll clearance that. Grounded right here down below. Don't have to worry about it below. And then as far as like having the shock sitting in the right place, you see what I did here. Just some masking tape just to hold it, because we're going to just rip that right back off as soon as we get this spotted in. So let's get it spotted. If you're welding anywhere near a shock and you have a chrome shaft exposed on that shock, put some masking tape, a rag or something on that shock, because you will, if you have any flash come off your weld, it will stick to that chrome and then that will cut the steel right out of that shock. I'm going to put 2 spots. Not wanting to build any heat at all in that. We've got all that stuff there. And so now that we've got that, we're going to take this thing back apart and weld it up. I think I'm going to stop there and let that cool. I don't want to cook that ball joint to death. That is a new ball joint, so that's not really, it can take quite a bit of heat, but there's no point in us pushing our luck. Alright, we got her welded in there solid, pull it back down. And I put just a little bit of clearance on the back. I'll clearance it more later. So now at this point, I really need to depend on the shock to hold everything solid. So what I'm fixing to do is I'm going to take me some pieces of metal and I'm going to take some vice grips. I'm going to clamp this shock up, make this shock be immobile where it won't move. I've put in some vice grips here to hold this shock where that it can move, but it's holding it in the right location. So let me show you. Or starting out where I think might be the right location. We gotta discuss that. So I just clamped the bar across the back, clamped some vice grips on. Now I've got this guide. So, and if you look, what I'm doing is I'm trying to make, you know, clearance here, in alignment, you know, in alignment still at 90 degrees there. Okay, so that's what's going on here. We've got a stand here that is my predicted rod height where I expect her. It's going to be very close. You know, obviously I may change a 1/4 inch, give or take, but I'm at rod height right now. But this shock has got to work at maximum travel in both directions. So we've got to take a jack and get up underneath here and do maximum travel in both directions. So I'm going to set this jack, pick it up, that's ride height setting, lock. And so now what I need to do is I need to go into full compression and see how much clearance that I can get. So we're going to call that maxed. Yeah, we're about to bottom the lower control arm. I'm going to add just a little bit more clearance. All right, now I'm going to let it all the way down. Now, so now I'm getting into my ball joint. So I definitely need this shock to be rearward more. So I'm going to unclamp. I'm going to move this whole assembly rearward a little bit and come over just a hair. I may have to. All right, get your clamp down good and tight. Don't want it to move. All right. Let's get that 90 degree setup back going here. All right, so now we're in there. Back up, and let's look. Good clearance, good clearance, good clearance. No problem with our spring obviously coming up. So that's a good spot right there. Let's talk about as far as, all right, so I'm gonna set it back on its ride height. So I'm gonna move my jack just a little bit. I got my block right here. All right, so there's ride height. Next up is the jack bolt itself, which of course is bolted tight. Now on this one, let me get her bolted here. On this one, it's gonna get tricky, but we're gonna handle it. All right, pull our bolt out here, and I'll put it on the shock. The bolt itself needs to continue the exact line of the shock. So as we run it in and out, we don't want this bolt mounted straight up and down, because if we mount this bolt straight up and down, as you go up or down, it's changing where the shock's located. And then you could change the, we have a good setup here. We change how our bump works. Now we don't have a good setup. So exactly in line, front to back, side to side, and everything. So what I'm going to do here, you think about this. I am going to have to probably make a guess. I'm at ride height, and I know that at ride height, I don't want to be on my bump. I know I want to be about 1 inch above my bump is where I want this to be. This is just from experience that I've got. And I want to be in the middle of my adjustment. I'm going to use this lower nut. And I know I'm going to want to come up 1 inch, and these nuts are 1 inch thick. So I'm going to take that one off. I'm going to do some measuring, and I'm going to set this nut. I'm going to set my jack bolt with basically the bottom of it at my center, because I know I'm going to come up 1 inch. Now I want to have lots of adjustment on this, and one of the reasons that you want to have lots of adjustment for it is, I may go, like for example, if I switch to, maybe I want to get a bump that is taller, a lot more rubber or something. I want to be able to run that up. Maybe I go to a short, stiff bump, and I want to be able to run that jack down. So you really want to try to have this where you need it. All right. 3 1/4 off the bottom. So if we say that's us, that's our money right there. What we're going to do is we are going to take and we are going to bend 1.5 inch 0.95 tube, and we're going to target trimming it back. We're going to do a 90-degree bend in it. I'll show this in a second. I'm going to do a 90-degree bend in it. Here's my target. I want the 90-degree bend to be right there at the height in line with that nut. Now it's going to lean back. We're going to have to make a bracket, and we're going to have to cut some weird angles because it's going to be perfectly in line. But we're shooting for that 90-degree bend to be right through there. So that's what we're going to do. We'll bend it up and we'll leave it long. We'll measure and then we'll trim until we get there. We're going to do the right side all on its own, and then when we get done, we'll copy this piece for the left side. I'll want these two pieces to be the same, even if that means our shock mount has an angle down or something to work effectively. That's fine. I want this to be right, and I need this nut right here to be tied as close as possible to that tube. There is a tremendous amount of torque that is going to get created when you hit this bump hard. For example, if you take and you miss the cushion on entry, like you're trying to run the cushion up high, and you miss it and you slam out right front into that cushion, that bump right there is fixing to take a ton of pressure. It's going to transfer every bit of that right through into the brackets you use to tie this on. That's why so many people tear off right front shocks when they run a bump. It's not that it's destructive by nature, it's that it takes more engineering to make it work. So we are going to do that next. We're going to get that measurement. So just so we have a guide, I'm kind of just freehanding it here. And basically the center of the tube, I want the center of that tube to be 13.5 inches is what I want. So I'm just going to let that lay over. It's fine. Bend up the tube. and trim it to fit. I'm gonna cut a 48-inch piece and bend it right in the middle. That way I've got several inches on both ends to trim this in to fit. There's the center. Remember, we're gonna go for a 90. We may shorten it up a little more if we have a problem, but we know we're gonna go at least 90. I'd like to do it 90 because I have a 45 down leg on both sides. That's the center, and I roll it back. I'm going to die right there. Did y'all see how I did that? Use your cheaters, people. All right. I'm gonna put a little roll on that. If you haven't seen my earlier videos, this is a JD squared bender. Just a fantastic piece. Go back to some of my first videos. I go into a lot more depth on how this thing works. And I will tell you, I do love it. It has been a lifesaver. It's very simple to use. I don't know that it matters. Now, I am going to put this seam specifically on the inside. This is seam pipe. I use DOM and all the main points of the cage and everything. But I'm using seamed. That's my cost affordable solution. It's a mixture of both according to safety. And right there, lock it down. Alright, we are pulled up. Make sure our zero is on zero. Here we are. Clean it off. Let her rip. There it is. Like I said, love this thing. Does a great job. Good company, makes a great product, JD Squared. They are not a sponsor. I just like what they make. Here's what we're gonna do. I'm gonna go ahead and I'm gonna leave this side, this leg long, and I'm gonna cut this angle for it to sit right on this corner of this flat right here. And I'm going to get that angle pretty well cut. And then we'll turn around and we'll start trimming back this end until she gets down to that height I'm looking for. And hopefully we get it to merge together with that 45 degrees on both legs. Now, the 45 on both legs isn't actually required. I mean, I like symmetry, don't get me wrong. But it's not required. I do want to make sure both sides are the same. These hoops and the way everything connects is the same, because if we ever bend this car up and the car is not square, so to speak, and even side to side, it gets really hard to tell what's bent and what's not bent. So we do want to make sure that these are both the same on both sides. So if it's 45 over here and I make it 45 over there, it makes everything easier. If we ever really bend it up bad, we put it back up on the jig, we know that's what we're going after. Okay, it looks like a hot mess. I know, it looks like a hot mess, but I'm going to walk you through it where you can understand exactly what's going on here, because this is getting this tower exactly where it needs to be. And it's just a process of going through it. So here, let me show you. First off, we have to make sure that it's straight up and down. So I clamped a flat plate onto the side of this bend. 89.7, that was as close as I could get. I'm trying to get everything to work out. So we have to be in line this way. Then the next thing is I wanted this tower going over here to be in line with my frame. It says you think about long term having this car be square built and everything. So I have all my tubes in line on my chassis down through here. And so then I've got this in line the way I did this. I took a pair of some square tube in here. You see how I clamped it down through there? And then I measured the distance, and I've got it set 4 inches from this wall to this outside wall, 4 inches on the front, 4 inches on the back. So I know that this is in line, it's parallel. You with me? Like that. That was the next thing. Then turn around. I said I wanted to go for 45. I couldn't quite get there. Everything worked out and I was hitting at like 44.3 and I'm at like 46, 47 over here. I may be at 91 total on my bend. That's as close as I could get and get everything to work. So you see, by having this big piece of square tubing here, now I can use magnets to hold it. I got me a magnet down here, got that one propped up right into that corner right there. I'm gonna have to heat that up, turn that over just a little bit and tie that in. Mouth here cut. Of course, this has been slotted. There's a step right here in the frame, so we're slotting to it. It's not perfect. It was as good as we can get, and you can see I'm right on this outside wall here, and I am right on this inside wall right here where this comes across. I really love it. I think I was kind of lucky that it worked out that way. And then the jack itself is going to go on the inside. So take a look. See how that's going to, that jack is going to be on the inside. What we're going to do, and I've already checked, oh, let me come back here. And I've already checked and we can get that jack, if I would show you the jack. All right, so I've already checked and made sure that we can get that jack to be straight up and down in alignment on that inside right there. One other thing we had to check is we took the header and we held the header up here to make sure that our header coming out, you know, this path, it would not conflict with that jack right there, and it doesn't. It's fine. So we've got her all. She's exactly where she needs to be. This right front's our critical tower. Again, we're going to lock her in, and then we're going to turn around and we'll just duplicate the left side as best we can. So let me lock y'all down here. When we're welding this, these welds are going, the heat from these welds, it'll turn this big time. So we gotta, when you weld up something like this right here, you really gotta pay attention and walk around it and weld on the center, on the front and the back, weld in the center and then get your edges, because it's gonna turn it big time if you don't. Alright y'all, we've got mill scales cleaned off. We've taped up the threads, that way we don't drop a booger in it with a welder here. Made a little bit of groove in the nut right here where it would just fit perfect, and what we're going to do is we're just going to outline this. I'm just going to look like a rifle barrel down this jack shaft here, and I'm looking for it to be in line in both directions. That way when we turn it, it's keeping that shock in the exact same position. And I'm going to look back just a little bit here. It needs to go that way. And I think that's it right there. And so what I'm going to do is I'm going to hold it right there and I'm going to spot the nut directly. Okay, so let's talk about what's next. Just welding that nut to this tube won't never hold. And the reason it won't hold, it's not that the weld will fail, but what it'll do is it will rip the tube itself apart. The tube's going to come open at the edge of the welds. It'll rip it open. And so we've got to spread that load out. And what we're going to do is we're going to make us some gussets just like this right here. I'm just going to take some cardboard and I'm going to figure out what they need to look like. Try not to make them too ugly, but yeah, we're going to make us some gussets just to fit on there and weld into that nut. Let me take a magic marker and if I had a magic marker right here. Yeah, take a magic marker and kind of draw it out. I hope you're enjoying this. This is something I was really wanting to look forward to getting to. Was showing a BumpStop shock mounting system. And if you haven't subscribed, well, subscribe, people. The other thing too though is check out my description for this video. And we have got a channel membership that is for sponsorship. And so if you like it, smash the like button. But if you love it and you want to see more of it, you know, then consider becoming a member. It's $4.99 a month. Make a huge difference. We are trying to really ramp this up into something that really makes a difference in our sport. Oh, I like that. I like that. Here is the steel right here. We're going to take and just weld that in. Like I said, spread that load out. The one on the back, it will be different from the front. But before I weld those in, since the nut's in place now, I am going to go ahead and get the shock out of the way before I mess it up. We cut one more. We're going to put it, let's make sure I got it right. I think it's that way. No, it's this way. Put her up there and clamp her up. All right, we got her all bolted back together here. I'm loving how this turned out. I'm really liking, again, this is 1.5 inches, 0.95. I did a 90-degree shot when it was going for 45, ended up at 46, 44. I'm fine with that. But I did want to take and let y'all get an up-close look at how this finished out here. So you can see what we've got going on here. The way we bolted in, we got as close. I went ahead and cut this relief back so you could see that I wasn't crazy. There is plenty of room here, plenty of meat that's going on there. Gussets on both sides. Went ahead and put a little bit of paint where it didn't just flash rust on me here in the shop. But this nut is tied in very well to this. That's the jam nut to lock that on top. And then if you look, you see the jack bolt and the shock is in alignment here. And then you can see that we're in alignment here. The jack bolt and the shock is in alignment there as well. Another point that I wanted to show you is talking about just what it takes for one of these bump setups. And you see guys that'll put the shocks, you know, out here straight up. They'll tie in close down at the bottom. They'll tie in here and then they'll come straight up and they'll have 3 or 4 inches out from this tube. And that is, to me, that's not any good, because it's just putting so much twisting force and give strain on your A member right here that we've got. The way this is, I am literally pushing up and down on this tube right here. That is as strong as it can get. Of course, we are going to duplicate this tube on the other side, and then we're going to run a strut across, because any side force that we're putting on it at all, we're going to tie the two together. And that's going to help make all of this, where we tie back and everything, so much stronger. So here's the question, y'all. What would you do different? And on the next one, how could we make this even better? Leave me a comment. Let me know. And of course, if you like it, smash the thumbs up button. Thank y'all.